Hello, my name is Andrew Elshaw, and as part of my university studies, I have prepared a video on natural convection. This presentation is aimed at providing you with an understanding of what natural convection is, how it is used within the engineering profession with examples of its use, and to assist you with your development, I have prepared some reflection questions. To assist in your learning, I would like you to reflect on the following points. What is convection? What is the difference between natural and forced convection? List some of the applications of convection and how it is used within your engineering discipline. Natural convection is a mode of heat transfer which is void of human influence in the cooling and heating of fluids like gas and liquid. Natural convection occurs when the heat energy is transferred between a surface and a moving fluid at a different temperature. So how is natural convection created in the first place? The heat transfer between temperature differences creates a cycle called convection current, where the warm fluid is replaced by a cooler fluid. On a molecular level, the space between the molecules is expanded due to the increase of temperature, resulting in a change in the molecule's density. This results in the molecule becoming lighter, and under the effects of gravity, this will cause the heated fluid to rise until it begins to cool, before falling. The most notable advantage of natural convection is in its passive nature, which in turn increases system reliability. Forced convection works under the same principle. However, it involves human influences like pumps or fans to assist in the transfer of heat between the fluids. Heat transfer in natural convection is quite small compared to forced convection. The flow of fluid in natural convection is also much smaller than forced convection. Thus, forced convection will experience a higher transfer rate of heat. Consider the hot object exposed to cold fluids. The temperature of the surface of the object will decrease as a result of the heat transfer between the surface and the cold fluids. The hot object will be surrounded by a thin layer of warm fluid, and the heat will be transferred from this layer to the outer layer. The temperature of the fluid adjacent to the hot object is higher, resulting in a decrease in its density. Thus, the heated fluid will rise. This movement is referred to as natural convection current. Without movement, the heat transfer would be by conduction only, and the rate of transfer would be much lower as a result. Once the fluid has cooled, its density will increase, causing it to fall. In experimental conditions, it is possible to create a cycle by where fluid is heated and cooled. There are many occurrences of naturally occurring convection. Ocean currents and atmospheric layers are both examples of naturally occurring convection. The engineering application of natural convection is cooling of transformers, hot air ballooning, cooling of reactor cores, cooling of electronic devices such as chips and transistors by finned heat sink. In the hot air balloon example, the air inside the balloon is heated, causing a change in its density and thus creating lift. The hot air balloon will continue to rise until the density of the air inside the balloon is the same with the atmospheric layer. The air on the outside of the balloon will slowly cool the air on the inside, resulting in a higher density, causing the balloon to reduce altitude. Thank you very much for taking the time to listen to my presentation. I hope that I have been able to explain the topic of natural convection and its application in the engineering profession.